Now this time we're gonna go for, you can do the same thing for the second floor beam, so I'm not gonna do them, you can just do them the same. I'm gonna go for slab, so we're gonna go for first floor slabs, calculating reinforced concrete for slabs. Now it's very easy to calculate them. One thing we have to know, in order to calculate the slab reinforcement, it depends on the way that you calculate the beams. What we did when we calculate the beams reinforcement, we took the whole beam like this. For example, whenever we took the beams, we took the height of the beam fully like this. So what will remain, what remains is the area between the beams. I mean clear spacing between the beams, from face to face of the beams. We have to calculate those areas for the slab. Well, it's very easy. Why? Because we have slab names. So this is excuse me. Now we have different slabs. Let's say this is 101. They name it 101, slab 101, slab 104, 105, and each of them they have their thickness: 15 centimeter, 12 centimeter, 12 centimeter. For example, 102, or some they call it S1, S2, slab 1, slab 2, slab 3, slab 4, slab 5, whatever they name them, doesn't matter, each of them, but they have to have a thickness under it, or we have to know them. So the thickness will be collected on the plan, written under the name. This is one. Well, for the dimension, what we do, we calculate inside like this. Now we calculate something inside like this, the area. Sometimes we have minus. Now if this is a space, which is, I'm not sure, normally space, how do we specify an empty? By a cross with spacing. If you see any cross on the slabs, on a slab like this, basically means an empty area, maybe required for something. So there will be a cross sign like this, which indicate an empty space. We have to take care of them if you're calculating slab reinforcement. So here, I don't know, this small area, most probably it's a space, but let's say that I don't see any cross. I'll just calculate the slab as this. This is the area of the slab I have. The inner dimension, it's here given to us. This is 290 by, we have it from here till here, 395. So this is slab 1, we write it here, for example, whatever the name of them, it's D101, which is, I have one of it, and the dimension we're writing it 2.9, or can be writing it, this is the length, 3.95, 95 with 2.9, and the thickness of it 0.12 centimeter. So this is what we have for one slab. Well, if this area here, if this small area here, it's an area which we have to deduct it as an empty space, then we have to encounter how much is the distance, which is not given here. Most probably it's not. It's related to the reinforcement, most probably. But sometimes they will provide an empty space that we have it. If there is, you will see there's a cross sign. In this, we don't have it. In most of the buildings, if they are closed in the edges, they have some space in the middle of the slab for the lighting, so you will see it in different projects. Well, if you want to calculate, you go for the other slabs. Sometimes the slab, they will not be as easy as this. Like for example, checking 105. If you see 105 here, it's kind of two area we have it for 105. It will be something like this. We have this one, and we have this part. So you can divide it into two parts. For when you're calculating D5, you can say D105, for example, A, D105B, which you have to provide this is A, this is B, somewhere for people to know that what does A and B means here. So 105, this is two parts. So you're calculating these distances in order to have DO5's area. So you can write it A and B, separate these two areas. Now, there is a faster way to calculate the reinforcement for the slab if you have one thick and the same thickness slab. For example, here we have different. Yes, 15 I have it, 12 I have it. I don't recommend to go for the method I'm explaining now if you have different thickness for the slab. But if you have same thickness, for example, you have 15 centimeter for all the floor is 15 centimeter. Now I recommend to use this method. It's much easier to calculate, faster to calculate. What will we do even for the beams? Let's say that we have the same thickness. When we're calculating for the beams, we calculate the beams only this part. We're not going to calculate the whole beams. Why? Because it will be easier for me if I have if the slab thickness the same, if you have the same slab thickness for the whole part, I can use this idea. At the end, I will just calculate the whole area of the slab at once. It's much easier than going one by one. But remember, this is what you have to do when you're calculating the beams. When you're calculating the beams, you're not going to take the whole height of the beam. You're going to take this one. So you have to take the thickness. For example, here it's given 48 for the beams. For example, for this one, 48. Listen, you know the total height minus 12. You get this one. You can do this one as well. This is a different way to do it. In this case, what will we do? We calculate the whole area of the slab. The whole area of the slab, which basically, it's different color, sorry. It's different. So I can use the whole area of the slab. For example, I can divide it into two. This is 1 or 3 areas. This is even 4 possible to do them. This is another area, so I can just add all of these areas. Since they are the same thickness, I will get for the whole slab. Or we say that there is another way to do it. It's what? To calculate it like this and take out the extras. This is 1, so I'll take this extra out of it as a minus. This will be minus here, and this will be minus. It might be easier to do this one the way that we explained. So this will be minus, minus, minus. It's also a possible way, but remember, if you use this one, you have to, even for the beams, when you're calculating the beams, you're not going to use 0.6. You're going to take the thickness of the slab out of it. There's 2 ways, whichever you prefer, it's up to you. But remember, you have to be careful when you're doing the methods, not to take extra things and not to forget any part of the slabs. So this is how you do calculate for the slab. What we said, it's important. It depends on the way that, since we use the beams, we're going to take inside of the beam. So whenever you have a slab, you simply take what? Around the beam, because you took the beams into the consideration, full height of them, so you take only between them. Sometimes you need more than one area to do it. For example, let's say we have a slab here, so you're adding this one as an extra and an extra to the, for example, slab 103. So you calculate this one and you add this one an extra to the slab in order to encounter all the concrete that we have it. And that's enough to know about the slab. Sometimes we have the edge of the slabs like this. Remember the same thing, since we calculated the beams in this manner, you also take this one from the face of the beam to out. In order to calculate this one, imagine you have around the building. What will you do? You can divide this one into different area or different segments like this, the same way we did it for the beam. So you can do them in this manner, same way, name them, for example 1, 2, 3, 4, 5, and put them there, or you can sum them all together. It's up to you. Some people, they do what? They do it like this. They add this length, they add it to this length, they add it to this length, they add it to this length, and they will write it at once. That's also possible. But remember, if you do a mistake, you don't know where is exactly the mistake. But if you trust yourself, you can just simply, let's say this is 3 meter, this is 1 meter, this is 4 meter. I mean, instead of saying 4 times 50, 1 times 50, 3 times 50, you'll say what? 4 plus 4, 8 times 50, because the width of it is 50. Remember, there's a lot of way to do it. Find a way, whether separate them or you can this way sum them together. But remember, if you sum them together, you don't know where is the mistake. So if you do any mistake, you have to again start to calculate all of it. But here this is not a lot, so you can do it in this manner. You can just sum. When you separate them and you select how many segments you have it, then you can add the length of them together and multiply by that. Width of it, the thickness of it, will take it from here. Thickness of it will take it from here. And this is for the slabs. We have it like this. Now sometimes people will provide the slab which is for the staircase within the slabs here, but I will come back to it separately. I will do for the slab calculation in a different video. Remember, you have to carefully check if there is any other things as a slab. They may have extra things. For example, here, this reinforced concrete slab? It was not in the plan, yes, so there's not going to be reinforced, because look, the slab, reinforced concrete slab, finished here. This most probably may be something else made out of wood, whatever we have it here. Or for example, this staircase, it's not a part of the reinforced concrete. We have to know they made out of something else. Thanks for watching.